Only an idiot would buy an AMD GPU. You'll get nothing but driver crashes and you must just hate tracing rays. But only an idiot would buy an Nvidia GPU because you're just contributing to Jensen Huang getting another leather jacket. You hate getting good value. You're just turning on pointless features that don't do anything for you. Do you guys see what I'm saying here? Like, you can read the YouTube comment sections on videos like mine talking about GPUs. You can read subreddits about building PCs, just general forums about PC building. And there's so many heated opinions from extreme fanboys on either side of the AMD Nvidia debate, but that doesn't mean that you shouldn't consider which brand to buy, because there are definitely pros and cons to either of them. So should you buy AMD or should you buy Nvidia? Well, everybody ends up buying Nvidia. Well, but that doesn't mean you should, okay? So what am I getting at here? I mean, if we look at the latest John Petty research, we can see that in quarter 2 of 2023, 17% of people of GPUs sold were AMD, 2% were Intel, 80% were Nvidia. Quarter 1 of 2024, it moved to 12% AMD, so they lost some market share, 0% Intel, 88% Nvidia, and then those numbers continued into quarter 2 of 2024. Also, we could look at something like the Steam hardware survey, where we see different numbers, but it's still overwhelmingly Nvidia. We see 76.6% Nvidia, and 15.4% AMD, and 7.7% Intel in the latest Steam hardware survey. Now, why do these numbers not match up to these numbers? They're actually measuring different things. The John Petty research is looking at the GPUs sold during that fiscal quarter, whereas the Steam hardware survey is doing a representative sample of Steam users surveying what's in their system. And then, but you might have built your PC 5 years ago, so it didn't show up in the latest fiscal quarter, if that kind of makes sense. Also, the Steam hardware survey is doing it based on Steam accounts and some sampling of those Steam accounts. So if a bunch of Steam accounts use the same PC, that's not necessarily different PCs with different GPUs inside. So that'd be like internet cafes or just a family who all share the same gaming PC but have different Steam accounts, that type of thing. But no matter how you look at it, we see that it's overwhelmingly Nvidia. But I think it's not quite as simple as somebody who's just popping in to buy their own GPU is necessarily just buying an Nvidia GPU, because I think the overwhelming majority of gaming PCs represented in something like this are probably pre-built systems or laptops. And, you know, when I go to Costco, for example, to buy my groceries, I walk past some gaming PCs, and oftentimes I'll look at what's there, and they have gaming PCs with discrete graphics cards in them, but I don't think I've ever seen one with an AMD graphics card inside. It's always Nvidia, at least every single one I remember. It's usually something like an RTX 4060 or some other 60 class GPU in general. Same thing with when I walk by the laptops. If they have a discrete a laptop with a discrete gaming GPU, it's generally Intel Nvidia. And so that can, I think, skew these numbers compared to if we're talking about somebody who's researching building their own PC and buying what fits best into their budget specifically and for their use case, rather than being part of the general market. Because if you're looking at something in like the $380 range, NVIDIA's new options are the 4060 Ti 8GB. 8GB kind of sucks for almost $400, and this thing isn't even that performant. If I was going to buy an NVIDIA GPU in that type of price range, I'd probably have to go to the used market. For example, if I look at used GPUs on Jawa right now, I can find an RTX 3080 10GB for $385. And this way, I'm getting a little bit more VRAM. Sure, I'd like to even have more, but also I'm getting a lot more performance. Like if I jump over to maybe Tech PowerUp's relative performance chart, I can see that if I look at the RTX 3080 when compared to the 4060 Ti 8GB, it's like 37% faster for that same price. Sure, it's used rather than new, but also has a bit more VRAM. Anyway, also, I can save you $10 off your purchase at Jawa if you use code OWEN10. Thank you, Jawa, for sponsoring today's video. You can find a link to follow in the video description and or pinned comment. And if you're not sure what Jawa even is, well, in addition to having the best name for being a marketplace for PC hardware, they are the marketplace for gamers. They can offer the absolute best prices on custom pre-built PCs and gear backed by buyer and seller protections that actually matter. So if you're concerned about buying used, well, you get those buyer protections. Also, again, they have a whole bunch of pre-built systems if you don't want to choose your own. And if you want to fund your upgrade by selling your old hardware, you can sell your own stuff by becoming a seller on Jawa and making your own listing, setting your own price. But you can also, if you're just into super convenient, like I just want to get rid of these parts instantly, Jawa will buy both GPUs and CPUs by giving you an instant offer. It's extremely simple, takes all the hassle out of it, and it factors the shipping in and finding the buyer kind of into that price. So the way it works is you just give them details about your part. They'll give you an instant offer, which includes the shipping factored in. So you could then print your free shipping label, mail them the part. They inspect the part to make sure everything checks out. And then most sellers get paid within 1 business day after the part is received. So again, check out Jawa by following the link in the video description and/or pinned comment. You can instantly sell stuff directly to Jawa. You can become a seller on Jawa. You can look at the pre-built systems, look at the marketplace. And again, if I was buying a Nvidia GPU in that under $400 range, I'd check out that 3080 we mentioned. Anyway, so if we go ahead and jump back into what I'm talking about, though, about, okay, finding the best thing that's right for you. Well, okay, so if I'm planning a PC build and I have a roughly $400 budget, as opposed to buying a pre-built system, I could play around with some options, right? So I could go with, okay, what does AMD offer in this price point? Well, from their new cards, they have a 7700 XT with some models available as low as $350, and then some more close to what we saw for that 4060 Ti 8GB, right? So which one's better? They cost about the same. Well, a lot of this really depends on what you want to do with your PC, because they're going to be good at different things, and they have different pros and cons. For example, AMD often, but not always, offers more VRAM at the same kind of pricing tier. Here we can see that the 7700 XT is offering 12 gigabytes of VRAM, when the 4060 Ti 8GB was, well, offering 8 gigabytes of VRAM. So it's a 50% VRAM increase if you go with that AMD option for around the same price point. Also, they can have differences in their performance. If I pop up something like a relative performance chart that we just looked at a second ago from Tech Power Up, by the way, all my sources will be linked in the video description. We can see that the 7700 XT in Tech Power Up's numbers is on average about 14% faster than the 4060 Ti 8GB, and it costs less, and it has more VRAM. If you look at it like that, you can understand the comments where people are just like, well, buying AMD is just a no-brainer. You're getting more performance for the same price and more VRAM. Why would you not do that? You're stupid. You're just giving your money to Nvidia. Jensen's gonna get a new leather jacket. What are you doing? But the thing is, it's still not that simple, because it depends on what you want to do with your PC, because there's other factors, right? There's other features. This is just talking about basically just relative gaming performance without ray tracing enabled. It's not factoring in things like upscaling, DLSS, FSR, frame generation options. Are you using your PC for stuff besides gaming? So that's where a lot of the differences really come in, because the truth is, if you go back, for example, to what if you're doing something with your PC besides gaming? What if you're using your GPU for productivity workloads? That's where things get, again, you have to buy what's right for you. Because if we look at something like this is the market share. So imagine that you are programming some kind of productivity app, right? And let's say that programming it to have GPU acceleration for whatever features that would make sense for is going to take you time to optimize and offer that GPU acceleration. Well, and optimizing for AMD is a completely different workload than optimizing for Nvidia. And if you look at the market share and you're like, well, looks like most people have Nvidia. So, and you only have time to maybe, you're going to allocate your resources to optimizing your productivity app. Which one are you going to spend more time optimizing for, NVIDIA or AMD? Now, it depends on the specific app. Some apps are well optimized for AMD. So if you have like a business workload or some kind of productivity apps you use for fun, you would want to research those specific apps and what you do with them and look if they are well supported by AMD. And you can look up specific benchmarks of those apps, because that can be very, very different than the gaming performance numbers, just due to the fact that, again, a lot of software developers are just going to default to optimizing and supporting NVIDIA, and some won't get around to AMD or will just be less optimized for AMD. So that's a real concern for people who are doing that. But let's say you don't care at all about the productivity side of things, you just play video games. So if you just play video games, there are still some feature set differences to consider. Which is, for example, upscaling. So upscaling is basically running a game at a lower internal rendering resolution and then outputting to your monitor's native resolution. So for example, if you were on a 1080p monitor, you could run the game at a native 1080p resolution. It's rendering all 1920 by 1080 pixels. Or you could use DLSS or FSR at the quality setting with a 1080p output. This would actually drop the internal rendering resolution to 720p. I think it's basically, for the quality preset, a 2/3 of each axis. And then that's how much pixels it actually renders, but then it runs through a DLSS or FSR upscaling pathway to try to output an image that looks as close to a native 1080p resolution as possible. But the thing is that FSR and DLSS aren't the same upscaling algorithm, and in the vast majority of games and tests, like here I'm showing from Hardware Unboxed, especially if you look at it in motion, you'll see that generally, although apparently I'm not even rendering this at like full resolution, but whatever. Generally, you should follow the links in the video description. I'm not planning on doing a full deep dive into the upscaling quality, but generally, you'll see that FSR is more pixelated in motion, DLSS is more stable in motion, and DLSS in general looks closer to the native image. So it's, again, especially in motion where FSR breaks up. And if you're looking at, well, that's FSR 2.2, FSR has had some upscaling updates since then. There's FSR 3, there's FSR 3.1, and there has been improvements. But generally, if you look at the latest versions of DLSS and FSR, the hierarchy still remains where generally native resolution looks better than both, other than some isolated specific instances. And then DLSS generally looks better than FSR, meaning closer to the native rendering resolution. Now, if you look at higher resolution monitors, FSR generally starts to be more competitive, although still worse. At the lower resolution monitors like 1080p, there's just fewer pixels to work with, and FSR seems to struggle more. But the point is, so if when gaming, you're planning on using upscaling to boost performance at some cost to image quality, just be aware that while FSR and DLSS generally give a similar performance boost, the output image quality will generally look better using DLSS. And that is, in my opinion, for a gaming workload, the most significant difference between AMD and Nvidia GPUs is that access to the DLSS upscaler. Now, the latest quotes from AMD, I think it's Jack Quinn is a vice president in charge of their gaming division, has talked about FSR 4 and using AI upscaling and admitting that that's the future, but we still don't have any information on when that will be available or whether it will support current AMD GPUs or whether it'll be an exclusive feature to future AMD hardware that has additional AI processing capabilities. So for now, I would say for upscaling, that's a big deal, and it is a better experience on NVIDIA hardware. Another thing to think about is ray tracing performance, because when we look at something like, again, this relative performance chart, you do have the fact that, okay, in general, the 7700 XT, they have it about 14% faster than that 4060 Ti, right? True. So if I go ahead and pop into one of my own GPU review videos, here I was looking at the 7700 XT up against the 8GB and 16GB versions of the 4060 Ti. Here we're looking at Horizon Forbidden West at 1080p high settings, and sure enough, we have the 7700 XT popping in at 14% faster than the 4060 Ti's. Great. So that seems to line up perfectly well with that relative performance chart. But the thing is, if you look at games that involve ray tracing, we can see that difference can kind of fall apart. So if I go to a game with like super high ray tracing stuff, here apparently I'm flying around the screen pointing at things, as I tend to do. Here, Danielception. Anyway, if we look over here, we can now see that the NVIDIA GPUs are massively faster percentage-wise. But there's another thing we should look at here, which is, okay, the NVIDIA GPUs are massively faster, but are they actually running at frame rates that you would want to use, right? Because they're still only hanging out around 40 FPS. So that's the big thing where when you're looking at ray tracing and whether that means you should buy NVIDIA instead of AMD, I think some people latch onto that a bit too much, because depending on what performance tier of graphics card you're buying and what sort of frame rate you're actually targeting when you're gaming, I would argue that at the price points most gamers are actually buying, which would be, I think, in the kind of that $300 to $400 level, I don't think NVIDIA's ray tracing performance is all that compelling. And in the lighter ray tracing workload games that don't really push the NVIDIA GPUs that hard, they often don't push the AMD GPUs that hard anyway. And sure, the AMD GPU might be behind, but they're both kind of usable, right? So in these heavy-duty ray tracing workloads, like Alan Wake 2 path tracing mode, Cyberpunk path tracing mode, 4060 Ti hanging out at 40 FPS, and that is using quality level upscaling at 1080p, meaning you're actually playing on a 1080p screen at 720p internal rendering resolution. You're still only hitting 40 FPS. If we jump up to 1440p resolution or something like that, and maybe go with a more aggressive upscale, like balanced level upscaling, now we're hanging out at 29, 34 FPS on those 4060 Ti's. Now they're more than twice as fast. Yeah, the 16 gigabyte version is even 3 times as fast as 7700 XT. But is that relevant if you're not actually going to play at these settings? Because even at balanced level upscaling, you're getting a crappy 30 FPS, right? And I don't think most people are getting into PC gaming to play at 30 frames per second. I think most people get into PC gaming to chase higher frame rates or play a different set of games. Or honestly, there's a whole lot of reasons to get into PC gaming. That's a whole different video. Anyway, the point is that, okay, if we're looking at something like these relative performance charts, yes, they ignore ray tracing. But when you look heavily into ray tracing, you have to realize that those premium ray tracing experiences tend to be sort of playable once you get into cards like the 4070 Super, and like actually really enjoyable once you're getting into cards like the 4070 Ti Super, 4080 Super. And how much do those cost, right? Like if we're saying the 4070 Ti Super is kind of getting you that premium 1440p path tracing experience, I mean, now we're talking like $800, right? So are you buying in that price range? Because if you're buying, something for around $300, if I'm buying an RTX 4060 for around $300, I'm telling you, I'm probably not enabling the super heavy ray tracing experiences because my overall frame rate is just too low. It's just not strong enough, in which case maybe I should buy a, what's AMD got around here? The 6750 XT comes in at $300. Well, if we check the relative performance chart, 4060 versus a 67, is the 6750 XT even going to show up on this list unless I search for it specifically? Yeah, it does. Okay. So now we're talking about, I could get an AMD GPU that's about 20% faster when I'm not ray tracing. And at 1080p resolution, I'd rather not be upscaling because even DLSS doesn't look amazing on a 1080p upscale. 6750 XT can probably handle my 1080p monitor without upscaling, get 20% additional performance. I'm probably not using heavy duty ray tracing anyway. So that's where it kind of brings me to that use case scenario, right? So let me put it this way again. So think about how you're actually playing games, right? How are you actually playing games? Are you mostly playing like esports titles where you turn down graphic settings to chase a high frame rate? Because if that's what you're doing, you're probably not using ray tracing, right? In which case, that's not really going to be that much of a selling point. And getting more of that rasterized performance, non-ray tracing performance for the same price could be a really good situation, right? Whereas if you're playing single-player games and you are wanting to turn on those heavy ray tracing features and use a lot of upscaling to make it playable, playable, maybe you're actually having to buy pretty much at the high end. Maybe you're having to buy a more powerful GPU to even get there. Maybe that makes sense for you. So where that actually leads me, if you watch my monthly GPU buying guides, you'll notice that when I'm recommending GPUs under $500, I'm almost always recommending AMD graphics cards. because I'm not sold on NVIDIA's ray tracing performance as a major selling point at those performance tiers. Whereas you'll notice that once I get above the $600 price point, I'm generally recommending NVIDIA GPUs. Because, for example, if I look at, if I'm buying a $1,000 graphics card, so if I'm buying something like a 4080 Super, so I'm buying a $1,000 graphics card, AMD's top-end GPU kind of fits into that price range, like the 7900 XTX. The 7900 XTX, okay, it's $900. So it does save you some money compared to the 4080 Super. But if we check their relative performance, okay, the 4080 Super versus the 7900 XTX, if I go with Tech PowerUp's database, they're showing the XTX is like 1% faster on average. Depending on the game, it might be a bit more. So the point is, that's without ray tracing. But when you enable those heavy ray tracing features, now the 4080 Super can do path tracing in Cyberpunk. It can do path tracing in Alan Wake 2. The upscaler that you might be using in order to enable that looks a bit better. And again, if you're talking about that kind of price point, the difference between a $900 graphics card and a $980 graphics card suddenly doesn't feel like that big of a difference for those premium experiences, right? So in other words, if we kind of come back to the original question of the video, would you be stupid to buy an AMD graphics card? That really depends on your use case, right? So if you're going to be doing a lot of heavy-duty productivity workloads, you need to check if your apps are supported well by AMD. Because if you buy an AMD graphics card to do productivity workloads that aren't well supported on AMD, that would actually be stupid. But if you're going to, be planning on buying a $1,000 graphics card and playing heavy-duty single-player games with all the features turned up, and you're buying the XTX instead of the 4080 Super, I'm going to be honest, I do actually think that's kind of a stupid decision. And I might get some pushback in the comments section because, the XTX has more VRAM, for example. That's something I haven't actually touched as much about here. So maybe let's talk about VRAM for a minute, because that's sometimes the AMD selling point. So more VRAM is good if the card with less VRAM is running out of VRAM. VRAM doesn't really, having more VRAM doesn't make the game run better unless you run out, right? There's basically just, do you have enough? And if you don't, now your game can slow down and stutter or not properly load textures because it's having to access system memory. So a card like the 4080 Super has 16 gigabytes of VRAM, which for the vast majority of games and situations, even at extremely high graphics settings, 16 gigabytes is enough. Meaning that if you bought a 7900 XTX and now you had 24 gigabytes of VRAM, so that extra VRAM doesn't do anything if the game's only using 12 or 13 or 14, right? Now, are there some situations where maybe you're using a ton of VRAM because you load a whole bunch of custom textures and things like that into a whole bunch of mods on games? Yes. So again, that's where this is a lot, you really need to consider your particular use case. So if you know you're going to be doing a whole bunch of mods and a whole bunch of big texture mods, and that you know that those go over 16 gigabytes of VRAM, and you're not really doing the ray tracing stuff, well then maybe the 7900 XTX is actually the better purchase, right? So again, it's very unique to your situation. Whereas if you're going to be buying a GPU to play games on a 1080p monitor and you have a $300 budget, I've already said my opinion. I think that the 6750 XT is offering more VRAM, and do games go over 8 gigabytes of VRAM? Yes. So would 12 gigabytes be an improvement over 8? Yes, in games that are out right now, not having to wait for the future. And basically getting the same price for more performance. Neither GPU is that great at ray tracing, so I'm not that sold on it. And if I'm on a 1080p screen, I'm probably going to avoid upscaling as much as possible, and the 6750 XT can probably avoid that for a lot longer than the 4060 can. So in this case, would it be stupid to buy AMD if you're buying a brand new $300 graphics card? No, absolutely not for those use case situations. As we go down the performance stack, it gets even more egregious. If I was going to buy under $200, a 3050 8 gigabyte is kind of all Nvidia's offering for, it looks like most of them are right around $200. We have some a bit less. Whereas AMD, we could buy the previous generation cards like the RX 6600, which is also 8 gigabytes, coming in at about $200. But if we look at the performance difference, if we wanted to jump into the relative performance charts again, if we go ahead and pull up something like a 3050, We got to go pretty far down the list. This thing is not super performant. And if we look at the 3050 8GB up against the RX 6600, we're talking 26% better performance from AMD. Sure, when you're not ray tracing, but I don't think the 3050 is really a ray tracing powerhouse, so I'm not going to be using that, right? So once again, if I'm buying at this price class, is it dumb to buy AMD for those gaming situations? Absolutely not. So is it dumb to buy AMD? Not in a lot of situations. Is it dumb to buy Nvidia? Not in a lot of situations. Is it dumb to buy Nvidia in some situations? I really think that if you're just playing video games, buying a 3050 instead of 6600 for around the same price feels kind of dumb to me. Now, at the same time, I don't want to offend anybody with the whole, is it stupid, is it dumb? Because, first of all, the prices can be very region dependent. So you might be in a region where the pricing is just very different. Or like I said, you might be buying a pre-built system, which is what a lot of people do. And you might just not have a lot of AMD options to choose from. And pre-built pricing can be very different than just buying GPUs separately. So really the intention of this video wasn't really to call anyone stupid. It's more responding to the vitriol in the comment sections. So the long story short is there's reasons to buy AMD GPUs and there's reasons to buy Nvidia GPUs. And you should honestly just heavily research which one fits your use case best. And because it will be different at different price points and for different use cases for different people. And I hope this video was useful and or interesting to you. But hopefully what we can all agree on is that sometimes the best deals are on the used market. So don't forget to check out Jawa, the marketplace for gamers. And don't forget that I can get you $10 off your first purchase using code ON10, following that link in the video description and or pinned comment. And I hope all of you have an excellent day.